Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series of episodes where we are creating a programming language from scratch using C++, Flex, Bison, GoogleTest, ICU, a terminal window. Vim is our text editor. And yeah, if we don't write it, it doesn't exist. How about that? We have been doing the previous episode. We started a massive rewrite to the fundamental structure of how our virtual machine that we've written for executing this programming language, a fundamental change to how it operates. And that is how it tracks the values that it computes along the way. And yeah, it was huge. After the last episode, it was 2.5 hours long, and I didn't even know whether or not we were going to be at a steady state when it was done. So, and we weren't, by the way. I still don't know whether or not it's going to be successful because it won't compile. There's a compile error. And so this video is to make our change to shared pointers and GoogleTest work together, because that's the problem. They're not working together right now. So let's, part of the reason why would you watch this, maybe you want to figure out, this whole thing has been a performance art, right? You see me 100% live coding, nothing up my sleeves. I don't have anything pre-prepared. Solving the problems right here in front of you. That's been the goal, so that you can see the process. But in the process of doing that, hopefully you see, okay, these are ways that you can go about solving these problems. That's what we're doing today. So I'm going to go to the code, and normally, well, if I say git log, you'll see that the last commit was, it's what I did a couple days ago. The initial commit, that was the big commit at the end of episode 98. It's not even tagged, but you know what? Here's what I'm going to do. I'm going to say git checkout-b. So a new branch, because again, I don't know if this is going to be successful. If it's not successful overall, if it's not a performance increase, then I don't want to put that in my main branch. That's why I'm not working the main branch. But I don't know if I want to tag it as an episode yet, but we'll get there. For this, I'll do shared pointer experiment. Yeah, 2. So I've got this branch. On the right-hand side, clear up everything, make test, watch, and we'll get that compiling, and it's going to die when it tries to compile the tests. In fact, here, let's just get to that point. Make test-j8 and just make it get through everything as quickly as possible, because that's where the video starts. Is we're going to figure out why it's not compiling. And at the end of the last episode, quite frankly, I was really, really tired. And we were 2.5 hours in. And so let's see. Now, where are we? Okay, so we're trying. Notice we actually got through, if I scroll up, we got through compiling the shared library. It's just our testing is not compiling. And we were looking at this last time, and the problem is somewhere here. The error at the end cannot convert this SPCE. What is that? That is our new type that we've created, a shared pointer to a computed expression, SPCE. Oh yeah, it says that. To a bool. Why does it need to be converted to a bool? It says it can't do it here. Test.cpp line 31. So let's open that. Vim test test.cpp line 31. I'm not comparing it to a bool. That doesn't make sense. Okay, let's track this. What does this invoke? It invokes user include gtest.h that. So we're going to edit. Nope. There we go. We're going to edit user include gtest.h. $16.24. Okay, so we were, well, were we? This one right here, yeah, it's a not equal. It's the first not equal. All the others are equal, so it didn't error out on those EQs. It errored out on this not equal. Okay. And the reason I was looking at that, well, this is a macro for compiling, evidently, the not equal. And they use macros just like we were doing. Not equal, and probably should look and see how they did that. Using a macro to define a macro, it looks like. Because, well, here's why. Helper, op name, and no, they're using it to create an actual function, but that's okay. So over here, in fact, 1600, that looks like it is, there's a few lines up. Oh, this here. So an assertion of failure, format for comparison. That's what it is. And over here, that was 1600. What are the types? Because this is a template. Type 1 is our shared pointer to a computed expression and a float. Yeah, that makes sense. That's what we passed into the not equal. All right. gtest-printers.h. Okay, so let's edit that. User include gtest-printers.h line 415, and that's from here. And 415 return format for comparison T1 T2 format value. That doesn't tell me a lot, except I can see the types are shared pointer, computed expression, and a float. Makes sense. Go up to the next one, gtest printers 334. Print to string value. And my two types are my SPCE and a float. Okay. Go up to the one above that, 1018. Oh, that's right here. Universal terse printer of type T. Print. Okay. And that is computer expression and string of going into. Oh wait. No, the string is. Oh no, that's what it returns. But now we're down to so we're not even thinking about the float at this point. Okay, just the computed expression. 865. Universal print. Okay. And over here, T is a shared pointer to a computed expression. So 980, same file. Just jumping around all these templates. That's over here. Universal printer print value, and we're still a computed expression. Okay, 691. Print to, and it's in this static print that's in this class universal printer. Okay. The shared pointer. All right. 629. Print smart pointer output stream 0. Whoops, that's right here. All this looks normal if I can say it that way. 613. That's right. Oh. This is comparing the pointer to a null pointer. And PTR is the is a template type. Over here, T is computed expression, and PTR is a shared pointer to the computed expression. Okay. And evidently PTR, which is the shared pointer to the computed expression, when we're saying double equal null pointer, wait, are we at the top? Yeah. That gives the error. And where is that? That's what's finally being reported here. So on the left-hand side, edit/user/include C++ 11 bits shared pointer, line 444. That's the line. And it's in the operator equal of the shared pointer to the null pointer type. And it says return the not of that. And the error is can't convert my shared pointer to a computed expression to a bool. And that's what the not is doing, the exclamation point. Okay, why? The print is doing it, so it's not, I know that I'm giving it, this is a runtime check. Now it's saying if I'm a null pointer, print out the word null pointer, else, give the name and all that other stuff. Is it because I don't have enough screens? You're saying, Corey, you really don't? I really don't. I don't want to lose either one of those. Why is that so small? Did I open the wrong one? Yeah, I did. That's fine. Okay. I'm on this branch. I want to say, what is the diff between that and master? The red are my changes. No, I've got rid of garbage collected. So, yeah, red are my changes. That means green is what is in master. Wait. No, the SPCE stuff. The green is what's, yeah, what I'm working on. Red is in master. Okay, sorry, said that wrong. What did I do here? Assign index. That's, none of this would affect any of that. None of this. But I provided these Boolean operators for a shared pointer versus null, but the problem is I need it to be able to, I'm using null pointer PTR. So what all do I compare against? I compare against an integer, a float, a Boolean, a string, a const char, an error, and a regular computed expression. Should I be doing that? I think I wrote, didn't I write this one to replace the fact that I didn't have a... Okay. Why am I trying to do an operator double equal with a computed expression? I mean, with the SPCE. The reason is because... Here, I'm going to go ahead and close this because I don't think I need that. I don't think I need the shared pointer. And I don't think I need the GoogleTest. All right. So something like this. Result is no, it's no longer an optional. I got rid of that. It's just a shared pointer. And it's saying a shared pointer and a float. And I'm overriding all of this stuff. I think I was going about it the wrong way. Okay, so here's what I'm going to do. I'm going to open the include for garbage collected. That's first. Oh wait, garbage collected. I'm not doing garbage collected. I need my include for computed expression. And I wrote this, I don't think this is supposed to be here. Trying to convert it to a bool. I'm going to comment that out. And in fact, I already know I'm going to need to change this. So edit the source for computed expression. And where I was trying, yeah, this operator bool thing, I'm just commenting out because I don't think it needs to be there. All right. Now, I've got a bool is equal, but that's not, I want operator. Operator. I think that these should not be SPCE. They should be computed expression. Now, why did I have it as an SPCE? Well, we're using polymorphism and virtual tables. Not virtual tables, virtual things. So let's see. Let's do this. Let's say... That's right. So that I can say the right hand, I mean the arrow is equal, and it will, if the left hand side is a integer, it will use the integers is equal. Can we get that? I think we can do this. Okay, so here's what I'm going to do. First of all, tracked object, tracked object, tracked object. Okay, I'm going to say substitute SPCE tracked object. And instead I'm going to call this computed expression. Oh, oops. Nope, that was fine. We gotta do this again. Take that selection again because I did my command wrong. Okay, and now I need that same and I'm going to substitute instead of SPCE that is now going to be a computed expression. Okay, why did I just undo that? Because I want to say, okay, so this does say computed expression for null. And in fact, I think that needs to go away. But let me redo this. The one with the null, I think, like I said, I think that's going to go away. So what do I have left? I have comparing integer, float, bool, string, char, star, error. Yeah, this one, I think it's going to go back to a null pointer type. Null pointer type. Okay. Now, here, we're going to change SPCE for computed expression. Okay, this one is going to be null pointer type. Now, here's the problem. Computed expression is going to be give me a sec, I'm thinking. So computed expression is what we're giving it. So I need to get this sort of functionality. That is equal. So what is that going to look like? I think I need this to be, I need to get rid of LHS.useCount space double ampersand LHS arrow. And what will that become? It's going to become the memory address of LHS and then a pointer. And that should invoke the polymorphism. I mean Well, that didn't work how I wanted. You know what? Okay, fine. Okay, so I know 5DW will 5DW, 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 5DW. And there are no more. Okay. This now I need open ampersand close, right? Open ampersand close. Open ampersand close. Now, how can this get us into trouble? What if the left-hand side is a shared pointer to a null? Will that ever happen? Maybe. Oh, where? Oh, where? Oh, where? It's a lot of pages. Okay. No match for operator equal between Oh, this is in a different place. This is in our program execute. Let's look there. $384. So what is this? What is condition? Stack back. Stack back is a shared pointer to a computed expression, and now we can no longer directly compare that with double equal, but we can dereference it. We're going to have that. Look, that's going to be an issue here. There. I should have just hit ZT and that would have. There. There. Here. Those may be the only ones. If we get through program-execute, then all of those were correct. Yes, we did. So those are correct changes. Okay. This is still in the test. Oh my, this is... so far back. Templated errors have so many lines that they output. And here's the thing, I never want to see them all. I just want to see the very first error. That's fine. Give me all the information about it. Tell me all the options, and I think we're back too far. Let's see. Line 7. Here, we're in the middle of an error message, but just try to get an inkling of what's happening. Dealing with variants and test CPP line 7, that's going to be an include, so that's not really helping. Note. Let's look for a different color. How about that? Wait, there was one. Test CPP line 23. Let's look at that. Line 23. Oh, hey, it's the very first one. Or not the first. There's one above it. Execute returns a context. And what is result? Well, context is on result. Edit include context result. Okay, it's a shared pointer to a computed expression. That's fine. Go back. Oh, that's the thing. We need to dereference that. Oh no, we had stars. Okay, we have changes here. Git stash, that hides the changes. I'm going to stop the compile because I'm about to be doing some stuff. Git checkout master, and I'm going to cp test.cpp, and I'm going to copy that to test.cpp. Two. Don't worry, it's about to go away. I just copied the file. It's untracked, but I'm on my branch master, which means this is my original one. That's the point, because I made a big commit that got rid of all of those asterisks, and I think I just need to get them back. So there's probably an easier way to undo that with just that one file, but I don't know. Off the top of my head, it's faster to just make a copy. Now git checkout shared pointer experiment _2 rm test.cpp move test.cpp2 to test.cpp. So now I've got the original one there. And now bring back all my changes. Git stash pop. There. So before, that's what I looked at. I looked, and so I knew that I had not changed the test program. I'd only made changes to those three, so I stashed them, so it reset them, but it stored those changes within that branch. And then I deleted the tests and copied over the original blah, blah, blah. Now it's showing up as modified because it has all of those changes. So if I say git diff of test, look, it puts all of those asterisks back. And I think that that's what I want. So now if I make clean, make test, watch, get this started, everything should be good except the we're going to see what happens when we get to the test file. Look, and that even undoes this, what I was doing with the use count and 0. I don't need that anymore. I should be able to just compare that with a null pointer. Oh. That's going to be bad because I'm expecting them to be equal, which means when I dereference this, it will be a null pointer. We'll come back to that. Right now, okay, here's all of the compiles. Look, I didn't have to scroll back nearly as far. No match for operator equal. $1976. Okay. This sounds familiar. Oh, yeah. This is where we needed to declare the return type. Do I have any more of these? Yeah. This one, I think, as well. SPCE. And this one as well. SPCE. And I think I'd changed these. But, well, since I just reset the file, SPCE. SPCE. Here's another one down here. Okay, let's see if that. This looks different. Okay. Uh, Wait, is this the same error as before? I don't think it is. I just hit right again, making it do that. Um, Scrolling up 69 times. Yeah. No match for operator equal. On 1976. Oh, garbage collected. That's also why it sounds familiar. So, how did I do this? %s garbage collected SPCE. I remember doing this last time. I lost that. Okay. And now I need to %s SPCE make needs to become make shared. So only 51 times. We're doing better. No match for operand does not equal between computed expression and null opt t. And that is from test CPP line 66. Oh, it's no longer. So it shouldn't have null ops here. It should. All of the null ops should be null pointers. But everywhere. That should have been a %. Okay. That was only 16 pages scrolling up. Okay. Um, Still from line. Still from 66. Oh, this one. So everywhere that there is a null pointer, that one is correct. That one is correct. They all should have an asterisk. The get result, I may have to that's on the program. And it should be a no, it should be because it well, does it return a computer expression? Yes. It was 16. Now, completely different. 2292. Oh. Oh, I missed some get results. No. The get. I think all the get results need to be an asterisk. And I didn't do that before. Just look for those. Asterisks. Get result is the result of the program compiling, not the program running. Maybe we should. It compiles. We've got a segmentation fault. That's okay. We can deal with those. So, what are we going to do? We're going to run GDB with build apps test. Just run it. Got through a lot. That's good. Look at this line. And look at the error. Attempt to dereference a generic pointer. What did I say about the way I wrote it? It could be null. Okay. How do you fix this, Corey? Just for the sake of... Well, first of all, GTest test body test.cpp 1961. Okay, so 1961. We're expecting that. What is this? Edit. include program. What does get result return? An SPCE. Okay. Edit source program.cpp, and it just returns this. What if this result is always set? So result is right before annotations. So can I expect it to be at the beginning. There we go. We've got two constructors. Do I have result in there at all? Make shared computed expression. And if I put that, oh, that didn't work. It definitely didn't do what I expected it to do. It changed it to lowercase. Okay, make sure if I do that here. It's rebuilding program, shared library, test. We passed all the tests. Huh. I'm sorry, I know I'm just kind of sitting here in disbelief, but you don't understand how big this has been. What about context? Is its result always set? That's what I want. I just want to make sure. Edit. Well, first of all, B1. I would expect this to return a null pointer, but how do I... Can I do this? Both of those should still pass. So what is this doing? It's, yeah. Anytime is that what it was? Um, I don't remember what it was called. It's new in Firefox. It still keeps interrupting me when I don't want it to. That's what's new. C++ shared pointer reference. Use underscore count. Okay. And I would expect it to be equal to 0. Oh, no. Not equal to 0. So this will fail. Hopefully. Yeah. Okay. I would expect it to be equal to 0. Or not equal. This is, no. Well, that's not wrong. It's just I don't think that this is... Do I have anything for syntax error? This case. I want to see what this is doing. So in this case, it's a script that only has a comment. So there's no code whatsoever in this script. Okay, so it passed, but if I said EQ this will probably segment fault. It did not. So in my include dot context, context is an SPCE. In my source context, I'm not defaulting it to anything. In my program execute, get past my macros. Equals stack back. What if the stack doesn't have anything? Oh, the previous line says if there's nothing on the stack, put an error on the stack. So there's the stack, but what if we... So when it runs there's that. But what if we don't run? What if we just have an empty context? It's going to be a pointer to nothing, and I don't want that. Well, yeah, I think I want just a regular computed expression. I think it should do that. And now $18.95 is, it's still failing. Just want to see what this outputs. Notice I'm not trusting it. It's like something doesn't seem right. Result, error stack is empty. Because I executed it. Okay, so it's never, that's why I was thinking there's nothing to execute. Execute makes that check. It makes sure that there, doesn't it? When I call execute, no, that's call func. Okay. I create an empty context data. This one is while the program counter, which starts off at 0, is less than the bytecode size, but if there is no bytecode, the bytecode size is 0, so it doesn't go into this at all. So we can go to the end by hitting %, and it so once it, okay, so a program that is executed will never have a result that is and I think that the error is not wrong. There is no stack value. Okay, I'll leave it at that for now. And so and that's why, you know what? So we can say not equal here, and that it does equal stack is empty. Okay. These should pass, and then I'm going to do one other thing. Shouldn't that be correct? What's the other thing I'm doing? I was going to say auto context is equal to p1 dot execute, and then just context so it doesn't run it 50 million times. There's no reason for it to. Oh, and this should not be not equal. It should be EQ. It does equal it. Everything's passing. Okay. Remove my C out. And we're about to do the moment of truth. Is it faster? I mean, it looks like it's taking the same amount of time. Got to feed it in. There we go. What? Dude! Do you see this time? 0.35. It's never been that fast. And we're getting the right answer. What's going on? Valgrind. I mean, call grind, build apps, tang-s, feed in fib.tang. Do I have my command correct? Yes, and then just call kcache grind. Okay, so on the left hand side, I'm going to do okay, it's creating the call grind, but kcache grind of call grind out dot 6. That was the most recent one. It just opened here on this other screen. There we go. Whoa, look at this, look at this. I forgot that I was tracking this, but episode, what is this? We're on 98. Oh, wait. I don't think well, because we're not, might be able to. I know I'm arguing with myself. We're not even looking at this yet. Let's open it. K cache grind. Well, what's the name of the file? K cache grind. Call grind out 19387. Come on. There we go. So before we were looking at main and is that the, where's Notepad++? There we go. 39,041,922. Over here, I guess I'd be looking for shared pointer destructor. Operator delete. Maybe that's what it is, the operator delete. So there's not a direct one-to-one, or at least not that I'm seeing. But look at this, just in general, the numbers are cut in half, almost. Why? In our garbage collected thing, well, first of all, we were using an object pool, but we were still having to call the constructors and destructors. It's just we weren't doing allocations, so we thought. But when we created a new one, we still had to allocate the count. I bet you the shared pointer, the standard template library, only does one allocation when it needs to. Because we just cut our usage time in half. Well, okay, let's quantify this. But, wow. Okay. I still don't know what these are. Okay, here's what I'm going to do. I'm going to close that just because now it's time to look. This is exciting. Exciting for me. You may be sick of this and saying, Corey, finish the video already. But no, you don't understand. We've been waiting for this for a long time. When I look at the amount of time, almost all of our time is spent in execute. Makes complete sense. Within execute, we've got a lot. 13 million calls. What are these? Well, it's going further down, but It's something in the execute. And it's doing work. Counted base lock policy. Okay. Let's go the something that I recognize, something from mine. Free. There we go. Operator less than, shared pointer, shared pointer. Who is calling it? Whoa, look at that. 640 is calling this. The less than. This is the argc argc Oh, somebody makes shareds. This is okay. Let's see if we can find something a little bit more user friendly. What about the function? The call func. Because I know I do that a million times. Not a million, well, maybe a literal million. I don't know how many times we do it. Okay, so main. So that's something over here. Oh. Tang. Okay. No, call func. That's what I wanted. Right there. because it's being called specifically 2 million times. And in call func, there is this anonymous function that's calling getargc 2,690,000. So every time we've called this, we've had to. This is a 1-to-1. Okay. Argc. 197, 242, 290. Okay, so it's only 3 times and it's only once per type, right? Computed expression compiled function. This is computed expression native bound function, and then this is a computed expression native function. Okay. And so it's this one. It's definitely this one, and in fact, if we go to source code, it's, well, it's saying where it's call. But who's calling it? Right there. But we don't know. That one is not the same as this one. You know what I think it is? I think it's the static cast. I want to try something. Just want to. This may not even compile. But what it looks like it's doing is, in order to call argc, it's got to call an anonymous function to convert that. And the only thing I can think of is that this static cast is doing that. So maybe reinterpret cast doesn't. Okay. So it's compiled. We're going to time it. Not a big change, right? Still 3.5s. But I want to call valgrind. Let this run. And now I need kcache grind of call grind 19.3. That's the first one versus kcache grind of call grind 19.5. That's the one that we just ran. And all that I want to see and then we'll clean up our commit, wrap up the video. Video number 99. Wow. A huge thing. Okay. Call func. Call func. And here, call func. Is it making a copy? I said that was going to be the last one. I lied. No. This is going to just go down the rabbit hole because basically I thought, well, maybe call func, if it returned a constant reference to the actual variable, then it won't have to, because I think right now it's copying. Maybe that's why it's not optimal. I'll worry about it later. Let's clean this up. Okay, so the very last thing that we did, we need to undo, and that is the reinterpret cast. It should just be a static cast just like everything else. Now, git diff. Oh, we need to get rid of that. We can get rid of the virtual operator bool, and that's in computed expression.hpp. So vim include computed expression.hpp and source computed expression.cpp. Look for the bool. Yep, that one. And then this one is commented out, so all of this is where we're, yeah. A program adding a default value, that's fine. Now these are all of the change. There's going to be a lot of these because we were basically resetting it. Yeah. With the exception of somewhere up here, there was this one where I had more changes, but that's fine. Okay. And what is this? This is refactor complete. Program execution does not use garbage collected or singleton object pool. So, now what? I'm going to stop this on the right hand side for a moment because I'm going to do this. Git checkout master, git merge shared pointer experiment, git tag -a episode.098 -m episode.098 git merge shared pointer experiment 2 not tagging it yet. Because now, here's what we're going to do. I'm doing it. Oh my. Get rm garbage collected and singleton object pool. Get rm garbage collected singleton object pool was header only. Test get rm test garbage collected test singleton object pool. Make file. So singleton object pool is gone there. Oh, and test garbage collected is gone. So nobody needs garbage collected anymore. Now, one exception. So where's context? Computed expression and program needs computed expression, right? Because I set default values. So just making sure that those are. Now, make clean, make test. Okay, that's fine. That's why I'm doing this. Nope. Should have been test-watch. Why am I going through all this now? Because for the next episode, which will be episode number 100, yay, I want to do an overview of the language itself, and I want everything building correctly and just everything in good shape. That's the goal. Which means we're about to fix the make when I try to make it with -J8 or something like that, how it gives me an error. We're about to fix that. Okay, here's another one. Library base. Include computed expression library base. Tang.hpp. This can go away. That can go away because we explored the tail call optimization, whether or not it would work. It didn't. I wonder if now it would. I'm not trying it. I'm not doing it. No. All the other stuff is library stuff and the string views. I still think that would be a good thing. But for right now, garbage collected. I really think we should add everything else here, but we don't need to do that yet. We're passing our tests. All right. And this is final removal of garbage collected and singleton object pool. Comes full circle. These are some of the very first things that I wrote for this project, and well, live and learn. All right. Last thing. I keep saying last thing. Okay. What is the error? It tried to do all this stuff, generating the HTML escape scanner, Bison, all that. But it couldn't do opcode.o. Oh, wait. When trying to do Unicode string, it said no rule to make the target build generated Tang parser. Which is needed. So Unicode string has no dependencies. Evidently it does. Build generated Tang parser. Oh, so it's not the Unicode string, it's in the Tang parser, wherever that is. So remember, I'm doing multiple at the same time, so it had to wait until Unicode O finished. So that is, so this error here does not go with this line, right? I'm doing multiple things at the same time, and they're all dumping their output at the same time. I can't make, don't know how to make this needed by build objects Tang parser.o. Okay, so I'm looking at the wrong thing. It needs Tang parser.cpp and all this other stuff. Who creates Tang parser? .hpp will create the CPP. Tang scanner.cpp relies on Tang parser.hpp. Wait, but that's Tang scanner.cpp. Oh, should these... The error is that I think this should have been HPP. That's where it's created. Parser.cpp. Is it appear anywhere else? Nope, that's the only place now. Okay, I think that's probably going to fix it. And now if I make clean, everything's gone. Make J16. Why not? No errors. That fixed the make file. Well, I mean, it's still building, but... Wait, what? Thought it was good. No, I think... I bet the file wasn't fully generated. By putting this here, I think that's right. Try that again. Try to do everything at once. And I did put that back as, whoops. Tang parser.o is now relying on .cpp, which is relying on the .hpp. Did I just do something because I thought it was in the other window? No. Okay, we're good. Let's see. What did I type? Oh, I just typed -J16. I didn't do make tests. But either way, it's working. Make file. That's the only difference. Okay. All right. I thought I hit enter and it didn't look like. All right. So, where does this put us? We're here. We're going to redo our documentation. That's going to be big. And don't worry, we're wrapping up. Oh, whoa, whoa, whoa. Look at this on the right-hand side. Forget that. I mean, that's just saying it's really fast. 3 milliseconds. So we're right on the border of between 3 and 4 milliseconds. And we know it's happened. It's working quickly anyway because, well, we've seen that. So, get status. Get add docs. Of course, yes, we changed a lot of stuff. Get commit -m update docs for episode.099. Before I just want to make sure. Yep. That is where we are. 099. Just push that up. Get tag. Now I've pushed up master. Have I get push? Origin episode 099. I don't 098. I don't think so. That's fine. And now 099. So everything should be up there. If someone in the past goes and looks up 98, it should be there. The tag for 98, this one is there. And here it is. Call grind All of those gone. We're on a clean tree. Finally. All right, so what is missing? Oh, before we do that, how's our lines of code? We've dropped! And we doubled our speed. Well, it's because we got rid of stuff. That's all right. I can deal with that. Okay. What do we need to do for the future? We still don't have the library support. And how I envision that would be like being able to compile another shared library that you could then just say, hey, here's the path to that library, include it. And they would communicate, and it would add all of its functionality that it needs. That probably is very high level, but I see it working almost in the same way that, I'm not saying technology-wise, but rather conceptually, the same as an Apache module or a PHP plugin, right? Where you can basically just give it a path to a library and it will just work. Because it will load it itself, and they can communicate, they set up, they negotiate, hey, what do you need? And yeah, I want that mechanism, and it's probably not actually that difficult. It's per OS, but right now I'm basically writing this just from the perspective of Linux, so I'll probably keep with that for the moment. That's the first thing. The second thing is I wanted to be able to pass well, you can already pass a context in, but I wanted to make it a little easier to use, because the idea is that you would compile these scripts into a bytecode and be able to execute them multiple times, perhaps without having to recompile them. So imagine a program that has 1,000 scripts compiled and ready, and when it gets a request, it can respond by executing one of these and providing it the necessary filler variables, who the user is, and maybe a lot of other things, but and while it could do that right now, it's not very easy to use, and so I want to improve that. And then the last thing is, I think we can improve how we use our strings by using string views, which would reduce the amount of copying, but we're going to have to be a little bit smarter about how we use computed expressions, because computed expressions what I was going to say there, the problem with computed expressions is that they would need to reference the context in order to store the string, so that the string will go away when the context goes away, and so that's going to be a little messier, but I think it would give us some performance increases in a heavily loaded system. I don't think we'd see them as much now, but anyway. But the next episode is episode number 100. I'm probably not going to do any coding whatsoever, but I think I'll do a small presentation of what is Tang, why would you use it, the practical stuff, to help perhaps even non-technical people understand more about what I'm doing. Because, I've got plenty of friends and even experienced programmers that look at this and say, what is this about? It's a programming language. There's a million programming languages. How is yours different? I have answers for it. It just, you have to understand the paradigm that I'm approaching it from. So anyway, that's what I'm going to do. Thank you very much for joining me, and as always, I hope it's been helpful. Have a great day. Bye.